Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to discuss about the next session, next concept, Relational Algebraic Operations in DBMS. Relational Algebra Operations in DBMS. So relational means you are going to relate one table with another table. You are going to relate one table with another table. So from relations of the tables, how we are going to perform some operations to retrieve the values. We are going to perform some operations to retrieve the values from those two tables or from single table. So for that we are having some relational algebraic operations we'll discuss today. Right. So come let's into the session. So relational algebra and calculus. So relational algebra operations we are going to perform on the different tables. But before doing that operations, we have to know something about relational algebra and relational calculus. So what is meant by relational algebra actually? So generally we have seen that procedural language and non-procedural language. So procedural language, we know that what we want to do and what we are going to display. But non-procedural language, we are going to not able to display what I am going to get. So we can write the queries, we can write the syntaxes, but we are not able to understand that outputs, what we are going to get the outputs, right? And we are not executing also. We are not going to executing them also. But procedural language queries we can execute, right? So now we'll see what is meant by relational algebra. So relational algebra is a procedural language that can be used to tell the DBMS how to build a new relation from one or more relations in the database. How to build a new relation from one or more relations in the table or in the database. So how to build the relationship between the tables is very important. So building the relationship between more than one tables and that language, that is a procedural language, is called as relational algebra. Relational algebra. So procedural language can confine them to complete the relationship between two tables or three tables, multiple tables, right? So that is a relational algebra. It is a procedural language and that communicates, that maintains the relationship between two tables. And what is meant by relational calculus? So relational calculus is a non-procedural language that can be used to formulate the definition of a relation in terms of one or more database relations. In terms of one or more database relations. So it is a non-procedural language. So relational calculus is a non-procedural language that maintains the relationship between two tables, and it formulates the definition also. It formulates the definition also. But relational algebra is a procedural language. Okay, fine. But how those tables are related to each other, and tables are going to retrieve some values and with the help of procedural language as well as non-procedural language, we can have some fundamental operations to doing this relationship on the tables. So what are that fundamental operations? We'll see here. So some of them operations: select operation, project operation, union operation, set different operation, Cartesian product, and rename operations. So these are all some operators performing on operation. So relational algebra is a procedural query language. It gives a step-by-step process to obtain the result of a query. And this relational algebra uses these operators, all the operators to perform this query. Simple, I just want to display some values from the employee table. What I am going to perform? I can perform select operation. So select is a operator. Select is a relational operator to get the values from one or two tables. Right? So these are some fundamental operations. We will see all the different types of operations here. The different types of relational algebra operations are as follows. First one is what? Select operation. Second one is what? Project operation. Third one is what? Rename operation. Fourth one is what? Union operation. Fifth one is what? Intersection operation. Sixth one is differentiate operation, Cartesian product operation, join operation, and a division operation. Division operation. From all these operations, from all these operators also, you can apply the operators to perform the query. You can apply this operator to perform a query. That is nothing but operation under. Applying select operator, that means indirectly it is a selection operation. Applying project operator, indirectly it is showing the projection operation. So like that we can understand the operators and the operations concept. So select, project, rename comes under unary operations. Select, project, rename comes under unary operation. That means you can perform these all three operators on a single table as well as multiple tables. Operate on single table as well as multiple tables. So we can call them as unary operators also, or else unary operations also. You can say that it is a unary operators or unary operations also. So how we see the diagram, relational operators. So this is a relational operation maintains a relationship between single table or multiple tables with the help of some operators, with the help of some operators. That operators are select operator performing for selection operation, project operator performing for projection operation, union operator performing for union operation, set operators performing on set operations, set difference operator performing on intersection operators, Cartesian product performing for cross join operations, rename operator for renaming operations. So like the way we can have different types of relational algebraic operations or operators to performing that all the operations on single table or multiple tables. So we'll see how this all the operators contains the symbols and all. So first one is what? Select operation. So select operation selects tuples that satisfy a given predicate. It is denoted by sigma. This is an operator in the relational algebra. Sigma is, we can call it as sigma. And this operator, what it will do, it selects the tuples based on the given predicate. Given predicate is nothing but given condition. Simple like a sigma. I just want to display department number or employee ID equals to 4 from employee table. So like the way I can understand to retrieve the value of employee ID 4 from the employee table with the help of selection operation or select operator. So we'll elaborate this. Sigma is used for selection, prediction, or is used for relation, and P is used for as a proportional logic and formula of which make use connectors like and or not. You can use this and or not as a logical connectivities. If you want to apply conditions, you can use without use and or operators. You can simply like employee equals to 4 or something, employee name equals to something like that you can display. But if you want to use these operators, you can perform this employee ID equals to 4 and employee name equals to something. So for that purpose only you can use this and or not operators. This is the syntax, or this is the operator symbol for retrieving the values of employee or of the table with the help of selection operator. Next one is what? Projection operation or project operation. This operation shows the list of those attributes that we wish to appear in the result. So what are the details, what are the column names I want to display, so that all the values you need to mention in this symbol. So Rest of the attributes are eliminated from the table, and what you want to display, that you need to mention in the attribute list. So the symbol is what indicating the projection symbol is what, this one, and I want to display the column names like employee ID, comma employee name, comma salary, like that you can mention. So this is the operator, projection operator you can use for to projecting the values from the table, right? And the next one is what, union operation. So union operation, suppose there are two tuples R and S. Suppose there are two tuples like T1 and T2. These two are the two tables or two tuples. You can say anything. The union operation contains all the tuples that are either in R or S, or both in R and S. So they can perform union operation, and what it will retrieves all the values from the union two operations. So it eliminates the duplicate tuples. It is denoted by U. So union operation is denoting with U, and it retrieves all the values from two tables, including the duplicates also, not including the duplicates. So if you have, suppose this one have same value, instead of displaying two values, it displays only one value. Means that does not allows duplicate values. So union operation must hold the following conditions. R and S must have the attribute of the same numbers. So that means columns of two tables must be same. Duplicate tuples are eliminated automatically. If you have any duplicate tuples in the two tables, that will be eliminated. Automatically. And the symbol is what, R union S, or T1 union T2. So like the way you can mention it. And set intersection operator. So intersection is of what it will display. It takes the common values from the two table. And displays. Suppose there are two tuples R and S. This is R and this is S. The intersection contains all tuples that are in both R and S. So it displays what, the tuples in R, the tuples in S should be the same. That same values you need to display. So that indicates R intersection S. And set difference is nothing but you can say it is a minus also. Right? So suppose there are two tuples R and S. The set intersection operator contains all tuples that are in R but not in S. So it displays what? So this is R and this is S. So if R minus S means, it will display common values along with the R values. So it will display common values as well as R values, means left side values. So it is denoted by what? R minus S. So like the way you can see these operators. And here Cartesian product operators. Here one thing we have to understand, union operation eliminates duplicates. Instead of that all the duplicates, it displays only one value. But union all operator, if you are mentioning this union all in between table 1 and table 2, it displays all the duplicates from T1 and from T2. It displays all the duplicate values from table 1 and table 2. If you mention union only, it will include only one value among all the duplicate values. It will display only one value among all the duplicate values. But union all displays all the values from the table 1 and the table 2 also. Even the duplicates, how many of the duplicates are there, all the duplicate values will be displayed. With this union R. So this is the way you can understand. And the Cartesian product. So Cartesian product is nothing but it is used to combine each row in one table with each row in another table. Each row in one table. Table 1 row, table 2 rows is matching with all the values. Suppose T2 contain 1, 2, 3 and T1 also contain 1, 2, 3. Then 1, 1, 1, 2, 1, 3 and 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. So like the way it is mapping or it is multiplicating, combining each row from the one table to another table. It is combining from one table to another table. And it indicates what? Not E into D. E into D. Right? And the next one, rename operation. Rename operation. So generally, if you are performing rename operation, how can we perform? We can write like rename old table name to new table name. We can write rename old table name to new table name. But here in the relational algebraic point of view, you can indicate this row as a symbol to rename, and here you can mention the old table name is what? Student 1, and new table name is what? Student. So we can use this rename operator to rename student relation to student 1. So I am replacing what? Student 1 in place of student. So student is the old table name, and I am renaming that student becomes student 1. So the rename operation is used to what? Rename the output relation, and it is denoted by row. So like the way this you have to understand the renaming operation in the relational algebra, right? And the next one is very important thing, set operators. So we have seen selection operation, projection operation, renaming operation, and set operators we are going to see here. So the set operation is used to combine two or more SQL select statements. Combining two or more SQL select statements. So operators like union, intersection, minus, and exist operate on relations. So corresponding to relational algebra, the union symbol is what? This one, and the intersection symbol is what? This one, and the minus symbol is what? This one. Relations participating in the operations must have the same set of attributes. So the table 1 attributes and table 2 attributes must be the same. Table 1 attributes and table 2 attributes must be the same. So the syntax is, we are going to write here, the syntax for all the set operators what? Query 1 from the left side and query 2 from the right side. In between these two queries, we are writing a set operator. So now first one is what? Union operator. So the SQL union operation is used to combine the result of two or more SQL select queries. So if you have more than one select queries, you are not going to execute all them within a short time. So you can combine this all the tables and displays the result. In the union operation, all the number of data types and columns must be same in both the tables on which union operation is being applied. So when you want to perform union operation, the data type, number of data types and columns must be the same. The union operation eliminates the duplicate rows from its result set. So we already said that two tables can have same duplicates. Then instead of displaying two tables duplicate values, only one value it is going to display it. So the operation, how it performs means, we'll see. Select column name from table 1. So if you want to mention any particular column, you can mention that column names. Select employee ID or select employee name, select employee age. Or else you can perform select star from employee also. And union is the operator to performing combining. And next to select column name from table 2. This is the second query. So we already said that query 1 and query 2. In between that query 1 and query 2, you can apply this set operator. So this is the way you can understand this union operator. And next, union all. So union all operation is equals to the union operation, but it returns the set without removing duplication and sorting the data. So it doesn't displace in only one duplicate value. It displays all the duplicate values from one table and the second table. So if you have multiple duplicate values from three tables, it displays all the three tables duplicate values. It displays all the three tables duplicate values. So the syntax is what? Select column name from table 1, union all, select column name from table 2. So if you want to specifying for particular column name, you can mention that column names, or else you can mention that select star also, select star also. So this is the first query and this is the second query. In between these two queries, union all operator is a relational algebra operator or set operators you can consider. Next, third one is what? Intersect operator. So intersect operator is used to combine two select statements. It is used to combining two select statements. That intersection operation returns the common rows from both select statements. Common rows from both select statements. That means common rows selecting from two tables. So the table 1 and the table 2 can have the values and the same columns from the two tables that will be displayed. The column names and data types must be the same. And if it has no duplicates and it arranges the data in ascending order by default. If it has no duplicates, then it arranges the data in the ascending order by default. So the syntax is see here, select column name from table 1, intersect operator, select column name from table 2. Select a column name from table 2. So this is the way you can write in the intersect point of view. But in some databases may not be supported. But if you want to display the same result or same like that, you can use instead of intersect operator, you can use joins concept also. So for that purpose, you can write here select star from B, inner join with A using name. So like that, you can write the syntax using join operator instead of intersection operator. Right? So that is the way you can understand from this intersection operator. And minus operator. So it combines the result of two select statements. Minus operator is used to display the rows which are present in the first query but absent in the second query. So that means the table 1 contains some values, table 2 contains some values. So the table 1 minus T2 means it contains some duplicate values or common values. Among that all common values, it displays, excluding these common values and T2 values, it displays what? Only the T1 values. So you see here, which are present in the first query but absent in the second query. It has no duplicates and the data arranged in ascending order by default. It has no duplicates and data arranged in ascending order. So if you see syntax here, select column name from table 1 minus select column name from table 2. So in MySQL, minus is also not working. So instead of minus and intersection, we can use this join operators also. So for minus purpose, we can use this left join operators. So like the way you have to understand the minus operator, set operators, and set relational algebraic operations. So these are all the relational algebraic operations, set operators. So we can see one example. Suppose you can take one table T1 and another table T2. So T1 table contains what? ID and marks. So that IDs for 230, 231, 32. These are the three values. 230 marks are what? 45. 231 marks are what? 50. 232 what? 55. And same way T2 contains also ID and marks. So here I can have 232, 55 marks, 233, 56 marks, 234, 57 marks. These are the two tables I want to performing all these union operator, union all operator, and intersect operator, and minus operator. See how we will perform. So first of all, union operator. So union operator indicates what? T1 union T2. T1 union T2. So in this, what we want to display, instead of displaying the duplicate values, only one value it is displaying. So only one value it is displaying. What? Like, so ID marks 230, 231, 232, 233, 234. Like the way only 5 values will be displayed. Instead of all two duplicates values, it displays only one value. Only one value. And the next one is what? Union all. So T1 union all. T2 means it includes duplicates also. So 231, 45 marks, 230, 45 marks, 231, 50 marks, 232, 55, as well as 232, 55 marks, 233, 56, 234, 57. Like the way it displays for union all operator. Next, intersect operator. Intersect the common values from the two tables T1, T2. The common value is what? T1 from the T1, 232 marks, 232 number, and 55 marks will be there. So only this value is going to be displayed. Only one value is going to be displayed. And similarly, T1 minus T2. So in this, you can use intersection operators also, as well as left values you need to display. So how it will display? So T1 minus T2 means the common value is what? 232 from table 1, or similarly 232 from table 2. So now it displays what? T1 minus T2 means only 230, 231. Only displays 230 and 231. Only two values. It excludes common values. It excludes B values, T2 values, and it includes only T1 values, not common values also. So this is the way you can understand all these set operators. Selection operation, projecting operation. These all operators are very, very important in the relational algebraic operations. So relational algebraic is nothing but what? Procedural language that maintains the relationship between all the tables, right? So this is all about relational algebraic operations. So what we discussed from this session, we will see. So different types of relational operations are there. So selection operation, projection operation, union operation, set intersection operation, set difference operation, Cartesian product operation, rename operations, right? So along with this, we are discussing set operators also. Right? The syntax is to write set operators is what? So writing query 1 and writing query 2. In between them, you can use this set operator. So like that, we can understand this all the relational algebraic operators to performing different operations, right? So that is all about this relational algebraic operations and operators, right? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.